Hello and welcome to this explanation video about Redis. At first I will show you an example setup where you could use Redis. Then I will explain what Redis is and why it is useful. Then I show you what protocols are used in the authentication process and which EAP authentication methods there are. At least I also will show you the whole authentication process. In our example setup, we want to demonstrate an isolated machine. This machine also contains other devices that have nothing to do with Redis and are only included here as examples. Then there are our important devices for Redis. The switch is the network access server and the M4000 runs the free Redis server in a Docker container. The unused ports at the switch are disabled and can't be reached physically. Only one service port is extended to the outside and physically reachable. This port is secured with 802.1x on the switch. The service client is then connected to this port and can authenticate in the network. Redis is an important authentication system in networks. The name stands for Remote Authentication Dial-In User Service. It helps to authenticate different users before granting them access to the network. Redis is mainly used in corporate networks and schools, both for Wi-Fi and wired LAN connections. Redis is very useful for distinguishing between multiple users on a network. This is important for multiple reasons. One very important reason is security in large networks, because if a user loses their password or shares it with others, they can be blocked and there is no need to create a new password for the entire network. Another reason would be that the logins can be logged. Redis could also be used to group users and put a different group of users in a different VLAN. Also, for the network administrator, it is important to be able to manage all users centrally in one place and be able to connect it to a higher and existent user database. Redis authentication needs multiple protocols to work. The first one is IEEE 802.1x authentication. This is the mechanism that allows devices to authenticate in the network to get access to it. The next one is EAP. This is the outer and unsafe tunnel and transfers the login details between the client and the network access server. Nowadays, it is used to transfer the details for a safe TLS tunnel with protected EAP. No credentials get transferred in cleartext through the network with this method enabled. Redis is the last protocol and is used between the network access server and the authentication server that runs Redis. The Redis server verifies the login details. EAP has different methods to authenticate. EAP TLS is considered one of the most secure options, as it relies on certificates for mutual authentication. EAP PAP and EAP TTLS both use a secure TLS tunnel before authenticating the user, with TTLS offering more flexibility in login methods. EAP MSCHAPv2 is a password-based method often used within PEAP or TTLS. Lastly, EAP MD5 is rarely used today due to its lack of security. Now to the authentication process. The first step here is the identity request from the switch after the client gets plugged into the port. Here the client responds with an anonymous username. The network access server sends this message to the Redis server, which responds with an EAP MSCHAPv2 access challenge. In the second step, the network access server sends this challenge to the client, which rejects the auth method because the connection is not protected EAP and desires protected EAP. The switch sends this message to the Redis server and it responds with an PEAP TLS start. In the third step, the switch sends this message to the client and it responds with an client hello. From here on, the TLS handshake starts. For simple overview, the handshake is shortened because it needs a few more steps. After the tunnel has been established, the Redis server sends an PEAP MSCHAPv2 access challenge. In the fourth step, the switch sends this challenge to the client. The client responds to the challenge because the credentials of the user are encrypted now. Nobody in the network can read them. The switch sends the encrypted credentials to the Redis server, which should check them. After validating them, the server sends an access accept. In the fifth step, the switch sends the success message from the server to the client, and with this message it accepts the client into the network. From here on, the client is connected to the network and has full access to it. To verify this process, we tested it in Wireshark. To do this, we opened a mirror port at the switch and redirected every traffic to our device. During the authentication process, we started the recording in Wireshark. With this method, you can get every detail, but also can't see the credentials in the TLS tunnel, because they are encrypted. The whole authentication process needs only a few seconds. Here you can see the whole process in Wireshark Live. This was a short explanation about Radius. You have seen an example setup for a Radius network. Then we clarified the question of what Radius is and why it makes sense to use it. Then we looked at a list of protocols required for the authentication process. Next, we looked at a list of different types of EAP authentication methods. Finally, we looked at the entire authentication process and checked it in Wireshark. If you want to learn more about Radius, then watch our other video about Radius. Thanks for watching and see you in the other videos.